Testing. Alright, let's get started. Okay. Welcome back, everybody. So this is now part 3 of the Adventure series. So today, again, just like to thank everybody for coming out today. Thank for watching videos. All these videos are recorded. They are put live on my Twitch channel. They're also posted to the JDE YouTube page and also my own personal YouTube page. So there's plenty of places you can find it. I want to thank JDE for helping me out with the stream yet again. They've been very, very helpful. So today's topic is that we're going to go over raycasting. So last week we created some elevators and a door to create a new room, because the next thing we're going to do is actually build some fun activities in this room. So the next thing I have envisioned this week is that I'm going to effectively create a system where my gun could actually pick up blocks. I can move around the screen, and then place them at another location. So we're going to create a simple pickup gun using raycasting. Okay, so to give folks a couple minutes again, if you have last week's one, you can start exactly from here. If you want to download today's assets, again, they're always going to be a download link on my... Oh, no, not ray tracing, raycasting. That will be a much later talk. Yes, I'll eventually do a ray tracing talk and eventually explain what actually that means. But no, today is just going to be raycasting. So how to actually effectively detect when things are in front of you using raycasting. So it's a physics tool. Now again, just like anything else, if you ever want to start from where my assets are, I always keep a little link here in my Twitch panel. And again, I'm just basically each week I'll put another adventure series. So today is week 3, so I'm using this file. Now all I'm doing is just adding on to the same file each week. But if you don't have last week's, or again, if you want to just start over, by all means, grab it. So today is all about raycasting. So we're going to basically cast some rays. So what does that mean? Well, let's start off from where we left off last time. So last time we created a couple new tools here. One, we created a little elevator, moving platform that moves it up and down. We created some different variants. Ones where effectively when I step on it, moves the platform up and down. We created one with code, and then this one's done with a sequencer. So again, each one of those guys are located in our blueprints tab. So we have one elevator that's just sheerly done with variables and moving actor world offsets. Then we also have another that we've been using, that we used a timeline for, which does a pretty good job of just creating a little simple elevator goes up and down, which we then use that same timeline to create a door here, such that when the player walks towards this, the door will open, leading into our next room, which is where we're going to eventually start building out our first room, our first little puzzle room. So let's actually start adding into this place. So eventually I'm going to lead to another door that we're going to jump out of here. So for the time being, what we're going to do, I'm going to duplicate this door. So we're going to build out kind of a room where if you solve the puzzle in the room, the door opens and leads us to the next room. Seems fairly simple. Now I'm going to duplicate this door, and I'm going to kind of put it over here as effectively allow us to create another doorway. So this will be door number 2. Now this door is going to behave different. We'll use this as a placeholder, but we're going to actually make it so that this door will only open if we actually solve the room. Now, in order to fit a spot to place it inside that, so I can actually get a hole in that wall to place a door, we're going to use a box brush. So remember last time we had this box brush that allows us to cut into other objects. We're going to do the same thing. So I'm going to go to my Modes tab. I'm going to go to, let's go to Geometry. I'm going to use a box brush. For that box brush, I'm going to make it subtractive, so I can cut into the wall. Perfect. And then I just need to scale it to more or less be the size of this door. Maybe a little too tall. Let's move this back a bit. Alright, that's getting pretty close. Now let's scale it down a little bit. We're not looking too bad, so that we have a little bit too much on that side. I'm going to shrink down either side. Alright, that looks good enough for now. Good enough for government work. So I like to keep things organized too, so I'm going to create a new folder. This will be doorway number 2. I'll put this door in doorway 2. Notch brush in there, and also put door in there. Also, the elevators I'll put inside, I guess we'll put in arena, which is our first room. Alright, that seems pretty straightforward. Now, what we're going to lead up to is that we're going to create a little puzzle mechanic. We're going to create a type of object that's such that if I place an object on something, it will then open up the door. So effectively a little pedestal, we're going to make it so that I have to place a block on the pedestal. If it's placed, then the door will open. Okay, so how are we going to do that? Well, first let's create the actual platform mechanic. So our little puzzle mechanic. So inside our blueprints folder, I'm going to create a new folder. I'm going to call it puzzles. So these are where all my puzzles are going to be. Straightforward. So I want to create a new type of puzzle. So again, since this thing kind of has screens that the idea that's going to have behavior to it, then that probably means I'm going to create a blueprint to do this. So again, anything that's besides just static objects, if they're going to have some sort of behavior to it, most likely you need to make a blueprint, which is what we're going to do. So I'm going to make a new blueprint class called, well, I'm going to make it a type actor. I'm going to make it puzzle platform. Call it puzzle platform. Very straightforward. Now, boom. I'm going to dock that one into here, and now we have our blueprint. So if you remember before, is that this, again, this effectively shows us all our tools that we can do for creating a new type of actor, a new type of game object. So I'm going to use this to create a new type of game object. All right. Well, what do I want here? Well, I need more or less kind of a pedestal to place things on, so why don't we just start off with a cube? So this cube, I'll call it the platform. Seems fairly straightforward. Nothing too fancy. Then, how about we create, so let's really drop in the scene and see what it looks like. Okay. All right, we have our little platform. Gonna stretch it out just a little bit, just make it look like maybe I need to place something on top of it, or even myself. That would be kind of cool. All right, perfect. So I'll then walk in here, check it's in. Perfect. There he is. Now, I'm also going to just start working inside this room. So I'm just going to move my little player object over into this room. So I just want him starting to work in here. Alright, now I'm in the room. So what I want to do is that, we'll start off is that if I step on this platform, that door should open. Seems straightforward. So let's try to create that behavior. So this is going to be a different type of door than we had last time. So the other doors that all you have to do is just walk towards it. We're going to have a different type of door. So I'm going to duplicate this, keep it kind of similar to what we had, but change some things around. So I'm going to take this asset, I'm going to select it in here, so it's in my blueprints door. I'm going to right click it, I'm going to hit duplicate. I'm going to call it door puzzle. Or puzzle door, I'm not sure. Oh, we'll call it door puzzle. And then I'm going to put inside my puzzles folder. I'll say move here. Actually, since we did puzzle for the first one, I think I'm going to try to keep the same naming system. Which actually, if I was more correct, I should be putting BP underscore puzzle door. And I should probably name this one the same. Put the BP prefix in front of it. So this is a naming convention that, again, whatever project you worked on, especially in a group, you more likely will take on a naming convention, which is what should be the rules when naming a new type of blueprint or object or eventually any sort of asset that you're bringing in. Now, the standard one for Unreal is that if you have a new blueprint, you actually put the prefix BP in front of it. One of the main reasons why it's helpful is that if, let's say our project gets so massive, we have a whole bunch of blueprints, so many files, so much stuff. Well, I can help narrow down what I'm looking for by doing BP underscore and then searching for effectively what I'm looking for. So it's effectively like first name, middle name, last name. Same idea here. So I'll try to be more technically correct. I'll name this BP puzzle door and BP puzzle platform. Seems straightforward. Now, I'm going to get rid of this old door because this one is the same type as the old door, which all I have to do is just get near it. I want to use my new puzzle door. Bring him in. Perfect. Line it up. Make that box brush a little bit wider. All right, that seems about right. Now, let's open up, and we're going to create a folder. Oh, actually, no, I'll put this in doorway too. Keep that organized. Now, let's open up the puzzle door. Oh, actually, sorry. Let's first finish this little platform. So we're going to do this in two stages. One, we're just first going to test to see if I can detect when I'm currently standing on that little platform. If I'm standing on this platform, then we are going to message the door to open. Okay. So I first am going to click the puzzle platform. All right. So we need a way to detect whether or not we're standing on top of it. So there's a couple different ways. We're going to use something similar to what we did last week. We're going to use a collision box. So if you do go to add component, there's a whole bunch of type of collisions. So these are objects, components that you can use to listen when eventually something's getting hit by something. In this case, I'm going to use this box collision, and I'll call it trigger box. Why I need this is I'm going to make sure I have selected. I'm going to bring it above the platform. So the idea is, if the player is colliding with this box, then I know that he's standing on top of the platform because that's where I placed the box. So the player has to stand on top of this platform in order for it to work. So if I look at our box in the scene, there it is. We don't put it on the side or around the sides or the bottom. We put it so it effectively collides with the top, which means the player needs to stand on top of it for her to see it. So let's test to see if this actually works. So let's go to our event graph. I want to effectively drive an event when we are currently standing on the collision box. Now, for any sort of collision component you have, if you scroll down, you get a list of events that you can do, which pretty much most components come with a list of events that you can do. Some more than others, but most static meshes come with a list of events, and all the collision bots come with a list of events. The one we're going to use here is called onComponentBeginOverlap. Now, if you remember from last week, what this means is that if anything effectively overlaps it, so effectively if they intersect each other, which is basically the player and this box, if they intersect, this event will be called. Now, it doesn't know what's effectively overlapping it, but if anything comes inside that little collision box, we will know about it. And that's what will happen here, which we can test out. Let's do a print string, which is always helpful to use. So print string, something, trigger, collision. Some message. Type in some message that we can listen to. So this message will appear if we're colliding with it. I'll hit compile, I'll hit save, boom, boom, boom. Let's run into here. Now, if we run in and stand on it, we should see a little message that tells me, hey, might be standing on something. Aha, there's our little message. Trigger collision. So anytime I effectively go out and into this effectively little trigger, I will be notified, which is what we're looking for. I want to know when I effectively touch this box. All right, that's pretty nice. That works. Cool. So now that we know that, so now we have part one done. Now, part two is that we need the door to open when this happens. So we're going to effectively separate it out into two parts. The first part is that we're going to have this thing, we're going to go to our puzzle door and add a function, basically a functionality, in this case an actual function, that if somebody would call this function, the door will open. So we're going to create the functionality of just like, hey, call this, door will open. So it's effectively, again, you're phoning your friend, hey, open the door. We're going to create that little interaction. So let's go to the puzzle door. So the puzzle door was right here. I will open it. I'm going to go to my event graph. Now, as you can see here, the last time we did this was we did this thing if someone entered that little collision box here, which we don't need that anymore. So I can even get rid of this door trigger. I'm not going to need that because that's not how this door is going to open. So I'll go in the puzzle door, I'll get rid of that little box and the little trigger box, and then come back to here. Now, what we're going to do is create a function. Now, we talked about variables before, so variables are containers that contain data. Functions are effectively a set of code that you can call. In this case, a function, you kind of think of as a command. I command you to do this. We could get the function a name, parameters, things to do. A function is effectively saying, if I say this command, you will do this command. So what we're going to do is, just like this begin overlap, we're going to take all the effectively logic for the door opening and wrap it into a function, wrap it into a single name, a single command that if someone says it, the door will open. So how we create a new function here. What we're going to go over here, and there's a little section called function. You're going to hit the plus button that says add function. And we're going to create a new function called open door. Now, when you do this, this will open up a new window. So we're no longer in the event graph, which the event graph is kind of like your base of operations where all your instructions happen. We're now inside the function called open door, which we just created. So this open door is now a function that if somebody else actually found this puzzle door and effectively is looking for it, it can then say, hey, puzzle door, open your door. It could then call it. So even here, so for example, actually we'll do it in two steps. Actually, yeah, we'll do it this way. So what I want you to do is that everything that we had from this on event begin overlap, I want you to take all these nodes, you're going to cut it, cut and paste, and you're going to paste it in this open door section. Oh, that's right, we can't do a timeline here. That's all right. Let's back up. I forgot one feature of Unreal. So I still want to use a timeline, but I forgot timelines can only happen in the event graph. So I'm going to do this a little bit different. So I can't do this here. All right, so we're going to do it this way. So instead of a function, we're going to create an event. So leave this, well, let's get rid of this function for now. So we're going to create something very similar to a function. So my apologies, I completely forgot. So this timeline object here, so we could do exactly what we did from our elevator. So this one, our regular elevator, not our timeline elevator. So for this one, we didn't use a timeline. We effectively used all the following stuff here, which we can do. Which actually, as a test, why don't we again show you both ways? So how about we do this? So we're going to still do the function, and then we'll do a custom event too. So let's still do the function once, and then you can do the custom event and see which one you like. So how about we do this? So we'll come back to this timeline thing. We'll come back to the timeline here. We'll come back to this. I am going to break this off, so I don't want to run this right now. I'm going to break this off. So just as a future note, if you're working on Unreal, this timeline can only exist in an event graph. It cannot exist in a function. It has to be a event graph that exists in. So it's a rule that they have. But so let's go to here. All right, what I want to do is I'm going to go to our elevator script. So I'm going to back up. So this is the step we're going to do. I'm going to go to my elevator script. So our first one, not elevator timeline, but our elevator script that has this code right here. Let's see. Actually, we'll remake it from scratch. We'll remake it from scratch in the puzzle door. Okay. Here's what we'll do. So we'll keep this timeline here for now. We'll come back to it. So let's just stick in the puzzle door so I don't confuse too many people. All right. Let's go to the actual viewport of this object. All right. So just like we had before, is that we know where this player starts, we know where it wants at the end, fairly straightforward. Okay. So what we're going to do instead is that we're going to go to event graph. We're going to create the functionality like we did last time, so we'll first create in this and then we'll move it to our function. So I want to show you that it's more or less still the same. So we know that the door, we're going to bring our door in. We know that we're going to take our door and we're going to move this door up towards that object. So we know we're going to take this door and move it up towards this little object, which we call the endpoint. So we need both of these guys. We're going to take the door, we're going to take the endpoint. Now we need the door to move towards the endpoint. So we want to create a direction that we want to go. So, just as a review, sorry, I'm going to duplicate this. So Okay. All right. Okay, so now I have my whiteboard. All right, so what we're going to do here is that we have our door. The door's starting point, effectively, its origin sits right here. That's where its origin is. We want this door to head up to where that little endpoint was, which I'll call EP. So if we have this door move towards that object, it'll look like the door is going up. Now, how do we calculate this? Is that, just remember this function. All this means is that you can get a vector, which is effectively the direction we want to go, by subtracting 2 points, effectively an end and a start. Subtract those 2 points, they give you the direction. So, i.e., in other words, if this is my endpoint and I subtract it from the origin, it gives me the vector between those 2 points, and that's direction. Okay, so I'm going to take this guy's, I want to take the endpoints. So endpoint first, we're going to take its location, world location. I'm going to subtract it from this guy's world location. Oh, actually, I think we already had start point, so I'll just use start point. So I'm going to swap out door with start point because I think I had that guy. Oh yeah, that was right there. So we use start and end point. So let's use end point, and we have start point. We'll use those two. So it's a little easier to understand. So start and end. That will give us our direction. Now we're going to normalize it. Now, why we're normalizing it, so if I bring up this picture, is if I applied this vector to this dot here, in one frame he will reach his destination because I effectively apply the full length of that green arrow. What I'd rather do is shrink that green arrow to a size I can control. And how you do that is that you take the vector, when you normalize a vector, it keeps the same direction, but its length is now 1. So its length is 1. Which means whatever I multiply 1 by, so let's say 2 or 1/2, the vector will become that much bigger or smaller. So that's how I control the speed. So I will normalize this, which will take the vector, shrink it down to 1, and then I can multiply it by whatever speed I want. So right now, the speed would be 1 because normalized shrinks it to 1. And then I'm going to multiply it by whatever speed I want. Da-da-da. So let's create a variable that we can control the speed. So I'll do Boolean float speed. And this effectively gives me my, I'm going to comment it, create move direction. So this creates the direction I want to move. So it's straightforward. Now, what we want to do is take the door, and we'll actually do this in stages, so how about we do this? So let's create another variable, and we'll call it move direction. And we'll make this a type vector. So the direction I want to move. So I'll drag this out, say set. Boom. Put that down, that down, that down. So we're going to keep this with the on overlap so we can see the test first, and then we'll move it to an actual function. So I'm going to drag this out and say the word sequence. So if you remember from last time, sequence effectively says to do this, then to do this, then to do this, then to do this. So the first step is I want them to create the move direction. We'll line that up. There we go. Create the move direction. And then we're going to move the door by that direction. So add world offsets. Add actor, so in this case, add world offset, which is just a component. I'm going to drag this over here. And then what I want it to move by is that move direction we set first. Boom. So this creates a little move direction. So this will move the door. Now, right now, there's nothing that's going to stop the door from moving. Hold on. There we go. So there's nothing that's going to stop this door from moving. Just checking my feed. Oh, the keyboard commenting. So the effectively comment a section of code here. Just click and drag all the nodes that you want, and then press the C key. C for comment. Cool. And I'm going to let this, and then move the door. Cool, cool. All right, so now we have these two. They both look pretty good. So why don't we test this out just to see if it works now. I'll still need the trigger box back because I got rid of it. So sadly, I'm going to get rid of this one for a second because I accidentally deleted it. If yours is still there, you're probably good. I accidentally deleted mine. So I'll need to add the collision back in. Bots collision, door trigger, I'll call it. On begin overlap, which is what I want here. So this will start, well, actually, I take that back. We'll want to do this on event tick, but we're actually going to do this differently. So actually, we might not need the trigger right now. I just want to see that the door opens. So we'll just use event tick. So I take that back. Let's just use event tick. So I'm not going to worry about the door trigger because we're not going to need it in the end. So I'll just get rid of that. All right, but there is one more thing I did notice I forgot to do. Anytime we're dealing with movement, to keep it consistent to the frame rate. So this event tick is going to run as fast as it possibly can, which is fine, but we only want it to move at a effectively speed, which again, a speed that we like. So for example, we wanted to move it over 1 second rather than 60 frames. So if you want to become frame rate independent and not effectively frame rate dependent, so what I mean is that this door, as it stands right now, if I do event tick, will move as fast as my computer can run it, whatever the frame rate is. If I want it to be independent from the frame rate, we got to use this little variable here called delta seconds. So I can either drag this over here, or I can just do this right here if I want. I can drag this out and multiply it by a float. And I'll do get world delta seconds. So it's more or less the same exact value as this is. And then I'll drag this in. So yeah, I'm just going to make one little edit. So it's frame rate independent. So this thing will now move in more or less seconds than it does frames, which is good. If we're frame rate dependent, then depending on how fast or slow the machine is, that's how fast it'll move, which is not not ideal. All right, looks like we got everything there. Speed. The speed variable, I'm going to come back here. We need to give it a default value, and otherwise we could also change inspector. I'll get the default value of like, maybe, let's say 10. It doesn't seem too bad. I'm also going to make it public. So remember, if you click this eye, it will make it public, which means I could set it in the inspector. Sorry, the details. So what I mean is when I flip this on, I hit compile, make sure it's green. If I go back to the main page, if I go look at this door now, this door, now you'll see a speed variable in the inspector. So now I can control the speed. So when I run, the door should start opening, which it does. Super slowly, but it opens. I'm going to change that value. Let's try 50. That ain't bad. Although, set that's going to keep going up forever, which is fine. We need to fix, but it will just keep going up forever. But the door will move open. So we're going to create one more little thing here just to make sure the door stops moving. So we're going to do one more step down here, is that we're going to take the door's position. So we'll grab the door, grab the endpoint. So we'll have the door and the endpoint, and we're going to check the distance between the two. Because at some point, the door is going to move up, and it's going to get really close to the endpoint. Once it gets fairly close to it, we know we've reached the end, we'll stop moving the door. So I'm going to take this, get world location. No, not set, but I need to get world location, not set the world location. Get world location. I'm going to do that the same thing with endpoint. Get world location. Cool. Get both of those. And then drag one of them off and type in the word distance. And look for the one that says distance vector. This will check the distance between 2 points, which again, these are 2 positions, where the door is and where the endpoint is. We know that the door is moving up towards it, so at some point this number is going to get very, very small. We'll say once the number is less than 10, we'll try that. Might have to dial this in, but we'll check if it's less than 10. Once we know it's less than 10, I'm going to drag this off. We're going to type in the word branch. So branch, again, there's no actual if statement node. It's now just called branch. That's what the name of an if statement in Unreal is. It's called branch. So I'm going to hit a plus button here. I'm going to drag that out. Now, another cool little trick in Unreal is that, again, I like to keep these lines kind of nice and neat. You can actually create little, effectively, little nodes on a line. Effectively, it creates basically more execution directions. I also use them for organization. So if I actually double-click this, if you double-click somewhere in the line, it creates another node, which then I can kind of stretch it out and keep it a little bit more organized, which I'm going to do here as well. Perfect. All right, that seems pretty good. So what if I know that it gets fairly close to it, it's right towards the end, then I'm going to create a little Boolean for me. So I'm going to go to variables. I'm going to create a variable of type Boolean. Is or at endpoint, question mark. So this is a variable that checks to see if we're at the endpoint. I'll say set. So I'll try this out, set it. If we're at the endpoint, then this is true. Otherwise, it's false. Yeah, the false part might not be necessary, because we're just going to open the door and let it be done. I have to think about that. Not sure if I want that one, but we'll leave it there for now. So why are we doing this? Is that this is going to check if comment, has the door reached the endpoint? All right, if the door has reached the endpoint, on event tick, I'm going to check. Let's see here, I will get it. I will branch it. As long as we haven't reached the endpoint yet, we can move towards it, but as soon as this becomes true, then let's not move forward. So that seems pretty straightforward. So it'll keep moving towards it. At some point, it will get fairly close to it. So let's say under 10 units, which means this is true, which means this will no longer run, because this says only run when we are not at the endpoint. I'll go back to here. I will hit play. Now it's going to be hard to tell if it stopped, but what I can do is I'll put a print statement here, just to test. Print reached endpoint. Just as a little test for me, just to see. I should see this message appear when it reaches it. If I don't see this message, I messed up. Let the door open. Oh, it reached it. Perfect. I see the message. It goes pretty far up, it looks like, but it did reach it. That's all I'm looking for. So, as you can see, this is a simple one-way. This will open the door will then open. Now, if you don't like that and you really are like Animated's like, I like the timeline, it's well, actually, before we get to that, let's also create this. So we're going to keep this, and we'll come back to how to use the timeline, but first we're going to show this as a function. All right. So is there any questions up to this point? So we just more or less created the move, basically the move behavior up again, and we now have it in its own section on the store. Okay. So what we're going to do now is take this exact same code, but now we're actually going to wrap it in a function. So just like you see this as its own little node, which effectively what it does is moves the character up and moves by world offset. This effectively gives me back a normalized function. We can create our own versions of these little nodes. And that's what we're going to do by creating a function. So if you haven't created yet, do create it. Hit the plus button. So I'll start over again. If you already have it there, just leave it there. Otherwise, hit function, create one called open door. Now, all we're going to do is take everything that we have right here and then drag it into that open door function. So what I'm going to do is click and drag everything here. So make sure I got everything selected. I'm going to cut by Control X, go to open door, and hit Control V and paste it. So all I did was just copy and paste this over to this function called open door. All right, cool part here is when I drag this over, now I have open door, which looks exactly the same. There's no difference between the two. However, I just organized my code because now if I go back to event graph, instead of doing that whole long line here, I could just say, I could just drag this function out here, drag it over. You can also just type here, open door, and it still brings it out. And I could just connect this to this. Now, if you run this, it would perform exactly the same as last time. Because all it does is that when it runs this blueprint, it will go inside this this function and run what's exactly here, which is what we created. So if I run it again, it does exactly what we did last time. No changes, but super helpful. Now, the biggest reason why we made this its own function is now once we made it a function and gave all that code a name, other blueprints could go look for that name and say, hey, if I found this function, I could call open door, which in this case, we're going to have the puzzle platform call this function called open door. So instead of on event tick, we're going to have this puzzle platform find this function and call it. So this is going to be the tricky part, which is, in this case, a little extra topic here today besides the raycasting. we're going to talk about object communication. So how do I get this object to communicate to that object? So there's several different ways. I'm going to show you the easy and probably the most flexible way. There are some other better ways in certain instances, but this is by far the simplest and the easiest one to do. So here's what I'm going to get my drawing board. So here's our goal. Nope. No, I want my little lasso. There we go. Delete. All right. So the object here is that we have our little, I'm going to draw this. This is our platform puzzle. Platform. And we have our door. And we know in here a door has this little function we just created called open door. Now, what we're going to do is that when the player stands on top of this thing, the platform is going to get notified from that on overlap. So we know we've seen that, which is right here, on overlap. Now, what we're going to do is overlap is then going to find the door. It's going to find the door, then find the function, and call that function, which will then in turn actually create our functionality. So the thing is, we have to find our function through the object, through the blueprint, and then we could go search it. We can't immediately, so from here, I can't immediately call open door. It doesn't exist because it has no context of what that means. So what I mean is just like, for example, if you had a cell phone number. Well, okay, cell phone number is allowed you call someone, but what would you need in order to call them? The actual cell phone. So you need a phone to actually use the phone number in order to call somebody. Same thing here. We know our function, open door, but we need the cell phone in order to use it. So that's kind of the relationship here. So what we're going to do is first get the puzzle door, and then from the puzzle door, then get the function. So what we need is that this guy needs to be aware that this door exists in the scene. So this is how you're going to do it. And again, you can use this in a lot of different contexts, but this is probably the easiest way. So what I want you to do is create a new type of variable here. Now, this variable, we're going to call it door. We'll call it puzzle door ref, R-E-F. This REF will stand for reference, which is, again, what we're referring to. So which door are you referring to? Now, the important part here is what this type is. Now, this type needs to be the same type as the object that has the function we're looking for. In this case, we're looking for open door. Open door belongs to the game object, the actor, BP puzzle door. So that's what this type of variable needs to be. So we're inside the BP puzzle platform. We created this new variable called puzzle door ref. We're now going to change the type, and I want you to type in BP underscore puzzle door. So you should see puzzle door. We don't need a platform. What we need is that the puzzle platform needs to be aware of the door. So we're going to go to that, and you're going to click object reference. We're not going to use any of these three for a while. All I want is object reference. So select to that. You do it, should turn blue. We should have some other things. So this shows that, hey, this is a puzzle door reference. It holds a puzzle door thing. So this is a variable that holds a reference to a puzzle door. So this is effectively our cell phone. We need now the problem is, all right, let's wind back. We created this variable. It's called puzzle door reference. It holds a type of object that is going to be the same type as this object, which is puzzle door. Now, once I have that, I could then use it. So, for example, I could drag this out, say get puzzle door ref, drag this out, And guess what? Open door is now here. Because in context of this variable, open door exists. So like, for example, context here, it's always important. So if you have a Boolean and you say add float, that doesn't make sense. So if I have a Boolean, so let me just use this example. I'll drag this out. It doesn't have an add float function because that doesn't make sense. It would have effectively I could set it to a branch because if statements take Booleans, stuff like that. So the only functions that appear here are in context to the variable I just dragged it off of. So Boolean, I would only get effectively function node, basically event and function nodes that are relative to a Boolean. Here, I have a puzzle door ref, which puzzle door has a whole bunch of functions, one of them being open door, which is what we created. So I now can use open door in context of this. So if I broke this link, this thing would be very upset. Or effectively, this thing would not even work. This would break on command, break when I run it. Because open door, there's no open door inside this script. But if I'm effectively in reference to this puzzle door, then I can use it. So that's what that target here means. So anytime you see a blueprint node with a target next to it, it's asking you is that, all right, in what context are you trying to use this function? So like, for example, if you're a Boolean, you only use Boolean functions. If you're a float, you only use float functions. If I'm a puzzle door ref, I only use puzzle door functions, which this is one of them. Does that make sense, everybody? I'm hoping so. Okay. If you have any questions, just type them in the chat. So now I have this open door function. Okay, all right. Now, here's the first thing. Even though this is I've just created a puzzle door reference in it. Remember, this is a variable. So imagine this puzzle door ref is the same as my cup here. Well, I can effectively drink from this cup. However, since it's a brand new variable, if I drink from this cup, there's nothing in it. I never filled the cup with anything. I could call basically drink cup, but there's nothing in it. I need to fill it with something. So just because I created the variable doesn't mean I can use it right away. I need to fill it with something so then I can use it. Just like with a cup, I need to fill it with water before I can drink from the cup. Just because I have a cup doesn't mean I can get upset that it doesn't have water in it. All right, so here's how we're going to fill in the cup, theoretically. So I'm going to get rid of this Boolean I create for that demo. So for this puzzle door ref, I want you to click this little eye symbol and make it public, which means I can then see it in the details panel. So hit the eye, make sure you compile, and then come back to our main page. Now, select the puzzle platform. If it's public now, you should see this new variable here called puzzle door ref. That is the variable that we created. It wants you to fill it with an object from the scene, because right now it says none, because the cup's empty. I can fill it with something in the room, so in this level, which is puzzle door ref. So I can fill it in with this puzzle door. Now, if you want to, let's say we have multiple puzzle doors, if you want to make sure that you're picking the right one, there's this little eyedropper here. If you click this eyedropper, it'll say no, 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 no. But if you highlight a actor that is the same type as this variable, I can then select it. So watch here, I'll select this, I'll clear it as none. I'll hit the eyedropper. I'll look around the scene, can't find it. Oh, there it is, left click. It is now filled with my puzzle door. So we have now filled the cup, which is super helpful. So now it has it in. Perfect. So what should happen here is now I'm going to get rid of this part. So I'm in the puzzle platform. I don't need that. What I want to do is that if the player steps on this, the door is going to open. Now, still will probably have an issue here because I only call it once, and I think this only gets called once. So we'll create a little functionality here. But as a test, because yeah, this needs to basically keep updating every frame, which we can. So we might change this up just slightly. Okay. But just as a test to make sure it works, I'm going to go back to puzzle door. I'm going to drag off of line 3, say print string, and say opening door. So I'll say opening door. So I just want to see this message appear. So if I did this correctly, when I step on this box, it will go to this function, which will jump into this function, go to here, it will run all this, and then say opening door, which is the message I'm looking for. Now, I kind of spotted ahead an issue that we're going to have, but we're going to fix it. So I'm going to run over here, jump, boom, opening door. So it works. Now, the reason why the door isn't opening is that this only gets called once. So on begin overlap only gets called the first time we enter the trigger box. It does not keep getting called as long as we're standing in it. And from what my knowledge is, yeah, there's no function that effectively keeps checking each frame. So we need to handle this. So we effectively need to trigger this on. Okay, that could work. So what we're going to do here, so we have a couple options. So this only gets called once. So what I could do is create a little boolean here that turns it on. So let's see how I want to do this. All right. I'm going to rename some things here. So open door. I'm going to create, so the function we currently have here, I'm going to call this open door update. So I'm going to call this open door update. I'm going to drag on our puzzle door, I'm going to drag on tick. So event tick, I'm going to drag this to door update. Okay, so door update then runs to here and then does this. Now, what I want to do is that I'm going to create another function here. So first up, actually, we're going to create a new Boolean here. So let's do Boolean. Let's create a new Boolean variable, and we'll call this open door question mark. So this Boolean is going to represent whether we should start opening the door. So what I mean is this. So if I brought this guy into here, open door, branch, boom. So this Boolean starts off as false. On update, event tick, we will only open the door if this is true. Okay, that makes sense. So this will only work when this is true. Then I'm going to create another function here, and this one I'll call open door. And this is, so our old one that was open door is now called open door update, which is effectively us updating the door opening. I'll create this open door, which all this will do is just set this Boolean to true. And then I hit compile. So what will happen here is that when the when the puzzle platform says open door, which we're going to change there in a sec, it's going to flip this Boolean to true, which then on the event graph, this will now run it, which is exactly what I want. That works for me. So now let's go to platform puzzle. Instead of doing open door update, I'm going to get rid of this one. I'm just going to change this now to open door. So hopefully I didn't confuse too many folks with that. So I'll run through it again. We now have two functions now. Open door update updates the door opening, which just constantly moves it. Open door just flips this Boolean value on, which effectively allows us to keep updating the door open. So open door update is what we had. So this was originally open door. I just called this now the update function for it. And open door just creates a Boolean that turns off or on. In this case, it just turns it on, which means in the event graph, and this starts off as false, which this would never run. But as soon as this gets flipped to true, boom, the door will start opening. Which means now when I run it, it should now open. Perfect. Now, that's one option. If you want to, so I'm going to give you another variation. So I'm just going to keep giving you guys some different versions of this, of what you can do here. All right, so this gives you flavor number 1. Now, flavor number 2 is this one. So I think I could do this. I'm going to show you a different form of this. So instead of doing it by functions, again, I would love to put this inside a function, but I can't. These guys live out, again, they cannot live inside a function. They can only live in an event graph. So I'm going to create a way I believe I can do this, do the same functionality here, but keep the timeline, because maybe you like the timeline better. You want to stick with that. So here's what I'm going to do. I'm actually going to create a custom version of this thing. So I'm going to I'm going to right click this open area and type in custom event. I'm going to call this open door event. So reds are events. So reds aren't functions, they're events. They're effectively alarms. So I'm going to drag this over here. Now, I believe this will now work. So if you like the timeline, you can keep this. And then we can create this open door event, which all I did was right click here and type in custom event, which then you click the first option. Which now if I go back to puzzle platform, I believe I now can call the open door event. Open door event. Perfect. So I could swap it for this one, which in turn would run the timeline rather than the other one. So this is a simpler one. So I want you to see both flavors. Again, there might be things you like that. Obviously, probably the smaller and simpler one is using a timeline to open the door. And I just created a custom event for it to be used. Again, the reason why I didn't put this in the function is that this thing cannot exist inside a function. It can only exist inside the event graph. Which now, if I run this, it should still work. Right over here. Perfect. It worked. Which actually, if you wanted to have the door close, if you want the door to close if the player leaves it, you could do something like this. Custom event. And type open, close door event. Close door event. And then I could say that this is going to reverse it. If this event is called, I'll hit compile. I'll come back to the puzzle platform. I'll go to the on trigger box, and instead of on begin overlap, I'll do end overlap. And then I will take the puzzle door ref, because that's who I need to talk to. I'll talk to the puzzle door ref, and I'll call close door event. Boom. Which now it should is that when I now jump on this thing, should open the door, but when I leave it, the door closes. So now if I try to run towards it, I can't get to it fast enough. So now we're creating a little puzzle here, so I'll even put it to the point where when I step on it, I won't make it to the door. See if I can get the correct distance for it. So, boom. Let the door open. Try to run towards it. Can't make it. All right. Any questions so far? I'll put this back up. So this is events and functions. So events and functions act very, very similar. The only difference is that events only exist in the event graph. Functions can exist in their own graph. So, and every blueprint can have any combination of blueprints, any combination of events and functions. Now, when to use one or the other, it's more for me, it depends on the situation and what I want to do. For this one, since it's very, very small, I think this one works fairly well. Timeline does a good job of simulating just basic movement. So I think I'll just do open door event, closed door event. But you have this here if you want to use the alternative version. So it should tell you that there is not just one way of doing something. All right. We now need to create our next functionality, which is, I want to do this. So I want you to go into basic. I want you to drag a cube into here, a new cube. As a test, we're going to have this cube open the door. Now, when you drag a new cube in, so every static mesh actor, you can actually have it try to simulate physics. So if you go to the cube actor, go to the details window, scroll down, you'll see an option called simulate physics. If you flip, so when I first run it, the cube's just going to stay there in the air, frozen. But if I select the cube and say simulate physics, it will actually fall down. Now it doesn't open the door yet because we haven't properly set it, but now it actually would fall on the platform. Everybody got that? So everybody has the cube kind of falling down. So again, you have all the settings you want to do in physics. So again, simulate physics, you can have it have yay or nay on gravity. So for example, I could keep this floating in the air with no gravity. If I shoot it, it'll start bouncing the cube off in the different directions because it has no more gravity. Yeah, you could probably have fun with that. But I'm going to turn gravity back on. There's also other stuff like constraints. So constraints allows you to lock certain parts of the physical object. So for example, let's say I don't want this thing ever to rotate. I could open up this constraints, lock all the rotation. So now if I shoot it, I'll turn off the gravity again so you'll see it float around. If I shoot it, it will never rotate. It will move, but it will never rotate. So, fun things you can play around with. Now for ours, I want to raise it above the platform and have it fall down. So my goal here is I'm going to have this cube fall down and hit this platform. Now, just like in Unity, the physics and the collision part are usually separated into two different things. These are all the physics settings, these are all the collision settings. Now, we'll play around with this collision stuff a lot more later, but just for the time being, the two ones that we're going to mess around with is most likely, if we're going to flip anything, it's the generate hit events, generate overlap events, and collision presets. The rest of these we're going to leave alone for right now. The only one that we want to turn on today is this overlap event. So remember how this thing is listening for on begin overlap? Well, we can have this object generate overlap events, which should trigger this thing saying, hey, something has overlapped them. When you have an object and this is off, it won't trigger overlap events. So I want this on. If I flip this on, it should open the door, I'm hoping. Well, you need to turn gravity back on. Gravity. Boom. And there's the door opening. But if I knock this out off of here, come on. door closes back. So this is kind of now the puzzle we want. We want to have it that the player has to place the cube on the platform. Because I could stand on here, but I will never make it to the door in time. I want to have it that I need to place this cube onto that platform. Any questions? All right. All right, so now we need to create the functionality of us picking up an object. So this will probably be this will take a bit, and this will probably be the last thing we do today. All right, so what I want you to do is I want you to go to the first person BP folder, look for one that says blueprints, and then look for one that says first person character, and double click it. This will open up the first person character blueprint, which is what we're actually controlling in the level. So this has a whole bunch of components attached to it. This has a whole bunch of functionality. So you can look around and check out what each of these components are. So if I can even go to the viewport. Oh, whoops. I want my event graph to go away. Go to viewport. This is effectively our gun. Now, well, I'll explain later why there's two of these, but effectively it's used for a couple things. Don't worry about it for right now, but our thing here is that instead of spawning a projectile, what we're going to do is basically spawn a little laser that's going to shoot out from our gun and to see whether or not we can pick it up. So here's our functionality that we're going to create. I want our little player, it's a little gun, has this little cube. I want him to shoot a laser, see if there's the cube there, and then I want him to be able to place the cube onto the platform. So I want the player to actually pick up the cube and place it on the platform. Now to do this, we need to know whether or not effectively we are actually shooting. So functionality here is that you see those little crosshairs in the center. I want to check to see whether my crosshairs are over that cube and see whether or not I can pick it up. All right, so there's a couple different ways that we can do this. So here's what we're going to do right now. So we're going to learn about raycasting. So if you check this one out, this comes with the default first-person shooter. So, and this effectively more or less just spawns a cannon into the scene, which you can have fun with. So by all means, take a look. Some of this stuff isn't necessary. So some of this stuff is if you actually want to run this on a phone or a VR headset, which I'm going to get rid of. So I just want this. I'm going to get rid of the touch stuff. So this is for VR. Well, it's here by default. So I'm just boiling it down to what actually is going on in our character as it stands here, and minus the VR stuff. So what's going on here is that this is effectively creating a projectile and figure out where it's spawning the projectile. So I'll walk you through this and actually break this down for you of what's actually going on here. All right. So I'll add some comments here. So this part right here. So we first have this little input action here. So this input action effectively is listening for a vent. In this case, it's listening for the vent is when we actually hit the mouse button, fire. Now, I want to show you where that actually appears. So I want you to go back to the main tab, go to editor, so go to edit, and then go to project settings. This has all the settings that can possibly be in your project. I want you to scroll down and look for one of the tabs here on the left that's called Input. This contains all the mappings for your effectively input from like keyboard or controller. And where it happens is mainly right here. We're not going to worry about the ones below, but just mainly right here. So this action axis, I want you to open it up. And you're going to see a whole bunch of stuff here. Some of them might look familiar. So one of them, for example, fire. So you remember called the input action fire. That's this guy right here. And if you click this little drop down, it shows you all the buttons associated with this little fire command. So if I hit the left mouse button, the right controller trigger, effectively any of the VR buttons, fire will, that event will be called. Because events are effectively alarms. Those that, again, this is an event. This event gets called when someone calls it. So effectively alarm. When this event effectively pings off, anybody's attached to this stuff will get called. In this case, input here. No, not editor. I want project. Project settings. There you go. This has all the buttons associated here. But like, for example, like at jump, there's spacebar, which is how we're detecting if we're hitting the spacebar. The WASD, so move forward. There's W, there's S. How it does it here is that it actually, instead of, so when you see action versus axis, so actions is effectively will return a true or false related to these key buttons. Axis returns you a number between -1 and 1. So mainly -1, 0, or 1. So for example, the W or the forward on your left joystick, it's going to give you a number between 1 and -1. So if I hit the W key, it's going to return me a 1. If I hit the S key, it returns a -1. Now, why they want the range there is mainly for like gamepads, controllers, because if I put a little bit on the joystick, I'm only going a little bit forward. I want to be able to detect that. If we're on a key, if I hit the key down, it's effectively the key's down. There's no like half a key press. But for a joystick, yeah, we have some flexibility here, which is why we're using a scale. So how this is used, for example, I'll go back to first-person character. Here's move forward. So ignore this section. This is still checking for, actually, so all we actually need is this. So I'm going to get rid of the VR part. So all I need is this one. So what this does is that when I hit the move forward, which is either the W key, the forward on the joystick, whatever it happens to be, or the S key, either one of those. If I hit the W key, this value will be a 1. If I hit the S key, this value will be a -1. Which what will that do is this. If you have any vector, and let's say this is forward, which is 1, 0, 0. If I multiply this guy by, let's say, 1, this remains 1, 0, 0. If I multiply this by -1, this becomes -1, 0, 0. And if I times this by 0, this becomes 0, 0, 0. What does that mean? Well, if this vector represents our forward movement, if I hit the W key, I would multiply this by 1. Which would remain exactly the same. If I multiplied this by -1, the arrow would point in the opposite direction, which would make me go backwards. And if I hit no key, this would be 0, which means the vector would be 0, which would be no movement, which is what's going on here. So that's more or less what's going on. So this one, in short, we'll be coming back more to some of these events, but in short, This one's just listening if we're firing. Now, to break down the rest of this, so if you want to play around and do some different stuff, this section right here is playing the animation of the gun. So if you notice when the gun fires, it kind of kicks up a little bit. That's what this part right here is controlling it. I'll give it a different little color. This part right here is calculating the direction of the projectile. So in short, even though we could kind of organize this weird, I'm going to make this bigger. Break each of these sections down, so you know. And when I put this up, you'll know. And if you want to come back and refer to here, you'll know exactly what these are doing. So I'll move this down. So this is the spawn location. So what they're doing, which is pretty clever, is that they want to figure out where they want to spawn the projectile from. Well, there's this little object here called sphere. Where that sphere is coming from is inside this component list. It's coming from this object right here, which is just a sphere collider. What they did was clever, is create a little sphere collider and place it right at the end of the barrel. So if I get the world location of the sphere, I know exactly where the end of the barrel is, which is smart, because now I know where to exactly spawn it. So this gives me the spawn location. Now this one part right here, ignore the gun little offset, so that's a little tweaking variable there, but what this is doing is getting the gun rotation. Spawn rotation, I guess. And the spawn rotation here is based off where the camera is looking. So wherever the camera happens to be looking, that's the rotation it's going to use. So for example, imagine if I'm the camera, if I look up, I want to look, basically the gun to go up. If I look down, I want the gun to look down. I'll get the rotation of the camera wherever it happens to be looking. Okay, pretty straightforward. Then they're going to basically wrap this all up into a transform. Which again isn't anything special. All they're doing is combining position, rotation, and scale, which is all the details you need about, let's say, any object. Let's say, for example, this cube. This cube has a location, rotation, and scale. All together is called the transform. So they're effectively taking those individual pieces and making a transform. In scale, they just keep it as one, so it's not bigger or smaller than it is. Boom. So this creates all the details of where it's going to spawn. Then this one spawns effectively a projectile. Spawn actor projectile. So this is the function you use if you want to spawn something into the scene. So if it's not currently in the scene and you want it to appear there, use this function, which you effectively give it a type of object you want to create, which in this case, if you go look in the blueprints, there's a blueprint that is called first-person projectile, which is this guy. You're saying that they want to spawn this guy right here. Then you need to give it a transform. Where is it going to spawn, and what direction it's going, which is this. And then finally, they created a little sound effect. So this is just a sound effect. So that's more or less it. Okay. So I broke down what's going on in the original. So this was already currently in the first-person project. This is just me showing you how it is. All right. So what I'm going to do here is I'm going to unhook the input action fire. So I'm going to right click this pressed here and say break, because I don't want it to spawn a projectile anymore. We're going to spawn our little raycast. So I'm going to go to pressed, and what we want to do is actually spawn array. Array is effectively, unlike colliders, which we've used before, which is detect when we're colliding with something, we also can create effectively a laser. A laser that tells us whether or not it's hitting something. So all we have to do is, for the laser, for raycast, it's effectively always made of a couple parts. So to create a raycast, you really kind of need 3 pieces of information. So you need a start point. You need a direction. And a length. And that creates a ray. So where a ray comes from, if you have a point, if you know what a point is, which is a position in space, a vector is a direction and length. You add them all together, you get a ray. So the ray is the combination of a point and a vector. That creates this. Now, in Unity, they do raycasting, and here they kind of do what are called line tracing. So same thing as a raycast, but instead of giving a start and a vector, you just give it a start and an endpoint, which we could still use from what we created previously. If I get a start direction, start point, and a direction, if I add those 2 together, I get the endpoint. So nothing really changes. So if you could do one, you could do the other. But what Unreal wants is a start and an endpoint. So we're going to create a new type of blueprint called line trace by channel. So line trace, so L-I-N-E, trace, T-R-A-C-E, by channel. That's the one we're going to use today. There's a whole bunch of different versions, but that's the one we're going to use right now. What this does is create, effectively, a line in the scene. So in order for it to work, so this is by channel, which by channel in this case more or less means that if the object's actually visible in the game, this line will detect it. Now there's some other versions like line trace by object, so I can have a raycast that only searches for certain objects in the scene, so that could be helpful. But we're just going to use line trace by channel right now. So we're going to say, all right, if I click this, I'm going to basically create a little line. Now, for it to work, we need to give it a start. We need to give it an endpoint. Well, the start is fairly easy. I want the raycast to start right at the end of the gun, which thankfully this thing setup's already created one for us. We're going to use that little sphere. We're going to spawn the ray right at the end of that sphere and then shoot it forward. So I'm going to say sphere. I'm going to grab the sphere over here. I'm going to get its world location. Get world location. And place that there. So that's where I want it to start. Now, where I want it to end is I want it to go a certain distance out away from the gun into the scene. Well, how we're going to do that is figure out that one right there. So imagine the gun. We know where our start is. We're going to get the forward of our gun. We're going to test that out first, but we're going to change it here in a second. Get the forward. So that, and then we're going to multiply that by some length, which will make this thing stretch out by a certain distance. So let's say 100. So if I get as forward, which forward represents the forward direction of this object. So in other words, if you look at this, this little sphere. See that little red arrow? I want the laser to shoot out away from that red arrow. So that red arrow is called forward. The green one is right, and this one is up. So I want it to shoot out from the forward. So from the sphere again, I'm going to say sphere, get forward. So that's this part right here. So we got the forward. Then we're going to multiply it by the length, which again, in this case, we'll even call it distance. So if I take the forward, which is, let's say, 0, 0, oh, I think it's 1, 0, 0, sorry, we're on the real. 1, 0, 0. Multiply it by, let's say, a 1,000 units. Then this vector will become 1,000, 0, 0, which is what I want. So that'll make this line go out 1,000 units. So I will take this, I will multiply it by, let's say, 1,000. So I get forward vector, which gives me my forward, which just, again, when you get forward, right or left, they return the unit vector, or normalized vector, which anytime you get forward, the length of it's going to be 1, no matter what. Then I'm going to multiply it to make it stretch out even farther. Cool. And then from here, I'm going to add those two together. So if I take this point, so if I take this, add this, I then arrive here, which is our end. So all we have to do is just add these two together. Which actually, if you want to separate them out to make it a little bit less, maybe a little bit more clear, I'll just duplicate this. So I'll leave that for start, but we'll get world location again. So same thing here. I'm going to add these two together. So from the start location, we will add 1,000 units out going in the forward direction, which will then arrive at my endpoint. Now, I want to see if it's looking right. So if you hit this drop-down box here, you can actually do some debug stuff. So right now it says draw time 5, which is you can effectively have a debug version of what this line is going to look like and whether it hits something. So what I want you to do, so just so you can see it, go line trace by channel, hit this drop down, go to draw debug, and say for duration. So draw the line for 5 seconds. Boom. All right, so we'll say 5 seconds. I will hit run. And I'll create a line. Not entirely correct, but it will create a line which will detect collision. Now, it's not firing the direction I'm hoping for, but I'll explain why here in a second. But you now should be able to fire lasers through the scene and see what it's hitting. It's red when it's not hitting something, and it turns green, and you see that little box of where it hit it. So if you see that little red box, little red box on the line, that's where it collided with something. So it detected collision. Now, why it looks off is even though it makes sense, so it should make sense I should fire out away from the gun, but that's actually not the direction I should be firing. I'm not going to fire where the gun's actually pointing. In most games, you're firing where the camera is pointing. So I don't want to fire where the gun's pointing. I want the projectile to start where the gun is. That's fine. But I want the direction of the shot to actually go where my camera's looking. Because right now, the laser's actually going out the same direction as my gun is. And my gun's kind of like below the screen. So I'm going to go back here. Even though it does kind of make sense, the direction I want to go is not, I don't want to get the forward vector of the sphere. I want to get the forward vector of the camera. So I'm going to get first person camera and get his forward. which is us looking out from the screen. Now in Fire, it should look a little better. Should now hit pretty close to the center of my cursor. It's going to be a little bit off just for the nature. I think the cursor is not dead center. I think it's a little low. But it should work. It's good enough for government work right now. But now I should be able to fire lasers in the scene and see where they land. Okay. So, pretty cool. Any questions? Okay. All right. Now, we're going to create, I'm going to get rid of this cube here. We're going to make a special type of cube. So we're going to go to our puzzles. So we have our puzzle platform. We're also going to make our, let's say, BP puzzle pickup. So it's effectively the things that we need to pick up and place in the scene. So in this case, I'm going to make it such that only certain objects I can pick up. Right now, we'll do this as the easiest way right now, just do it through a blueprint, but we can actually do this through the physics settings as well. So we can have multiple objects. Right now, we're going to only create that there's one type of object I can pick up, just for demoing purposes. So I'm going to create a new actor. So I'm going to right-click here, go to Blueprint Class, select Actor. I'm going to call this BP Puzzle, we'll call it Pickup. I'll open it. So I'll have to speed up just a little bit here, as that we're running low on time today. I'm going to do Add Component. We'll just use a cube, nothing fancy. Keep it more or less there. I'm going to turn on his physics, so I want this thing to have physics attached to it. That seems all right. And then I'll place it in the scene. I also will, before I leave, probably actually put a material onto it, so let's, again, something colored. But it should drop in the scene. And I can fire lasers at it. Now, what we're going to do is actually create some interesting functionality here. So what we're going to do is, now that I fired my laser, I'm going to see whether or not the laser has hit the object I'm looking for. So I'm going to show you one way to do this. So on the line trace by channel, I could search to see what I hit. So the first thing it does, it returns me a Boolean, which I'm going to use as a branch. So effectively, I don't want to go any farther forward if I didn't hit anything. So I'm only going to do the rest of the stuff if this line trace has collided with something. So if this is true, then yeah, I'm going to do this. Then you have also this other variable called outHit. This contains all the information about the thing my raycast just hit. So I'll drag this out. I'm going to hit break. And there's a little drop down here. Click this open. This gives you a whole bunch of information about the thing that you just collided with this line, this laser. Now, we're going to use, we'll come back and use some other things here for different flavors for other things. But all we're going to do right now is we're going to figure out what type of actor game object did I just hit with my laser. So there's one called hit actor. This represents the thing that my laser just hit. So I will drag this out. Now, what we're going to attempt to do here is what's called a cast. Now, later on we're going to switch this out because it's not the preferred way, but this is a simple way right now. We're going to attempt to cast this to BP puzzle pickup. So I want you to type in the following phrase. So cast, C-A-S-T, to, T-O, BP underscore puzzle, and you should see puzzle pickup. And then click enter, or click on it. You should then get this little blue teal looking object here. What this will attempt to do, which we're going to drag this off as true. So if my laser hits something, then I'm going to check to see if this particular actor was this type of object. It either is, which I can drag off of here if it actually was it. I also have this here, which is fail, which means it wasn't it. So I'm going to assume, I'm going to do a print string here, which I'm going to say print string found puzzle pickup. So I'm going to keep this right here. So this is pretty cool. What I've got to this point right here is that when I fire the button, I'm going to do a line trace by channel. I'm going to check to see if this object, if this line trace hit something. If it did something, which is true, I'm going to see if the actor that I hit is of type puzzle pickup. If so, I will print this statement. So this print statement will only appear if I've actually shot the correct object, which in this case is that one cube in the scene. I'll hit compile, and I'm going to test this out. So I fire my laser round, does nothing, does nothing, does nothing, does nothing, does nothing. Boom. There's the message. Found puzzle pickup. It only works if I've actually correctly shot the object I'm looking for. Now, how we're going to do this. So I only have 10 minutes left, and I might go a little bit over, so I do apologize, but I'm going to add the rest of this functionality. So what we're going to do now is, once I know I have this object, I'm going to make it appear as if it's floating in front of me, so I can control it. Well, there's a couple different ways you can do this. I'm going to show you probably the easiest method. We're going to create a fake object that is in front of the player that's going to more or less show where I want it to be held. Now later on I might create different versions of this, but what we're going to do, just like we have this empty object sphere representing the end of the gun, we're going to create another empty object that's going to represent where I'm going to put the object. So let's say we'll put it under FP, let's put it at under sphere. So we're going to attach this to sphere. So have the sphere selected and go to add component and type in scene. So this is a type scene component, which has nothing more than a transform, more or less just has a transform in it. It's just a dummy object, which is all I want. All I want this thing to have is a transform, which I'll click yes, scene. Now, just so I can see it in the editor, I'll also add a little billboard here. So I'll add a little billboard here, perfect. Boom, so I can see it. Now I'm going to drag this out. So I'm going to select the scene object, which, why don't we name that scene object and call it hold location. So this is where I'm going to hold the object. So I'll call it hold location, cool. I will drag this out in front of me. So if you notice, it moves with the object. So when I actually find the object, it's going to basically sit right at that position. So we're going to try that out. We'll do this as a simple test right now. So what I want you to do, first let's actually increase the distance my gun fires. So right now it's 1,000. Let's do like 5,000. Obviously you can dial this in later, but I'm just going to make it go really far. So I'm going to dial this up to 5,000. Now that I have my little hold location, I'm going to come to the end of this. So if I get to this point and I know that I effectively successfully found the puzzle pickup that I'm looking for, I'm then going to go to puzzle pickup. I'm going to say set world, so set actor location. So I'm going to say this actor's location is now going to get transported here. And where do I want to transport it to? So where do I want to send this puzzle pickup to? Exactly where this guy is, my little hold location, right outside here. So I'm going to get his world location and place it right into here. So what's going to happen is that this object's now going to teleport to wherever that hold location is. And then I'll hit compile. So I'll go back here, run. Oh boy, okay. Do I need to flip this on as teleport? I need to test that out. It's movable. Set actual location. I don't think I need these on, so it should teleport. I need to do print string. So I'm going to print string here, see if I reach this part. Yeah, I'm doing something wrong here. Wonder if I have to turn the physics off first. So let me test out one thing. So I'm going to turn these back off. So I'm going to turn this guy's physics off. So we might have to turn the physics off before we can move them. So, I'll just go to puzzle pickup. So go to the puzzle pickup object. I'm going to go to simulate physics. I'm going to turn that off. See if this will move them. Hit run. Okay. All right. So it looks like I have to turn the physics off before picking it up. That's fine. So let's go back to here. So all we need to do, I'll turn puzzle this part back on. Perfect. So we'll come back to the first person. So before I teleport him, I have to turn off the physics. So I'm allowed to teleport him. So here I'm going to drag this off. I'm going to say set physics. Or is it I think it's simulate physics. Simulate physics. So yes, there it is, set simulate physics. Perfect. So I'm going to show you what I did again. So I dragged off the BP puzzle pickup and I typed in simulate physics. So how do I know that? One thing to always just be wary of. Usually whatever the name of the variable is what you can search in Blueprint for. So eventually I just want to turn this checkbox on and off. So what I want to look for is simulate physics, since that was the name of that variable. So set simulate physics cube, which is what type of object that was. It's a cube. So I will turn off the physics and then move that right there. I'll hit play. I should now, whoops. Should now be able to go through the scene and then, still messing up. So set the physics. Let me turn that on. Will that work? Tested this earlier. All right, what did I mess up? So now if I turn the physics off, oh, let's check to see after I shot the cube, did its physics turn off? All right, let's run it. Boom. Then I'll hit F8 to depossess it. I'm going to see what the cube is. Is the cube still have its physics on? Nope, no longer has the physics, but he no longer teleported. Well, we'll just skip a step here. I think it will work after this, but what we'll do is just turn the physics off, and then we'll do the following. So I think this will work, but maybe it's just, I just can't move it more than a little bit per frame. So we're going to skip to the end spot, which you're just going to add a little bit more to this to get it working. So I think this will still work. So what I want you to do is create a new variable here. So once we've actually shot this thing, we're going to store off the object that we just shot. So what I want you to do is go to variables and a new variable. We're going to type into here BP puzzle pickup and say object reference. We're going to call this held object. So this represents the object that I can hold. So held object. This thing is going to be the same type as this puzzle pickup. So when I drag it in, I'm going to click set. I'm also going to break this off for right now. We're going to put this up at another location. So as soon as I shoot it, I then am going to say, this is what I'm currently holding. Now, what we're going to do is on event tick. So find your event tick event. If you can't find it, just right click and say event tick. What we're going to do is that every frame, if we're currently holding an object here, so remember, this is a variable, this is a cup. It can have something in it or it might not have something in it. So what we're going to do is that we're going to check if the held object, and you're going to take held object, drag it into here, and then say is valid. There's a one that says is valid question mark. What this blueprint does is check to see whether or not this variable has something in it. So is the comp empty or full? If the comp's full, then I know I have a held object, which then I'm going to continue forward. So what I'm going to do here, if I currently have a held object, I'll turn off his physics. So I'm just going to start from here. I'll just drag it off this one. Held object, simulate physics. Perfect. Turn off the physics, so false, and then set his location to wherever the held object location is. So I think this will work now. I'll hit play. Okay, I teleported myself. Oh, up. Sorry. Again, that might have been one of the issues. That actually was the issue in my last one. The set actual location, I was setting it to myself. I should have been setting it to the object. That's why I didn't move. Okay. So when I said set actor location, I should set the held actor's location. This. When this was broken and said self, this was referring to me. Which is why I didn't see the cube move, because I was trying to move me, not the object. I want to move the held object to this position. Okay, so that makes sense. Everything's right in the world. Now if I run this, no. Okay, what did I do now? Should work. Alright, I'm going to try moving things around. I'm wondering if this set physics needs to only be called once. I wonder if I can't set it in the same frame, same point that I'm moving it. Or most likely there's just something simple I'm just not seeing. So, okay, held object, that looks fine. Oh boy, okay, what's going on? Which, I mean, if I turn this off, simulate physics. If I turn off the simulate physics, it then can move. Alright, I might need to open up my other one and see what I'm missing. I wonder also, is it too close to me? Okay. Move that a little bit farther, and then let's turn the physics back on. Oh! No? Wait. No, that should work. Alright, I'm just not seeing it. So turn off the simulate physics. What am I doing here? Physics actor. Let me try this. So just as a simple fix, but I don't think this is why I'm having the issue. I'm going to set its collision to. I'm going to turn off all its collision. I'm going to see maybe that's causing the issue. So let's put that into here. We'll say set collision enabled to false. Nope. All right, we're getting to that part. So, man, I just can't see it. Should teleport me to it. All right, so let me see this. Teleport, whether the teleport state visits collision, if visits true, the velocity change, false. I don't think I'll do both of these. I just want this guy to move. I wonder if I do the set location of the cube, even though that doesn't seem right. Let me get the cube out of him. Set world location. Should be able to set the actor. I don't think I need to set it this way, but I'm willing to try different ones right now. Well, he definitely moved. Oh, forgot to set the world location. Huh. All right. So it was set actor that was the issue. I need to look up to see why I wasn't able. I should be able to just set the actor since it's the root object. Or is it not the root object? My puzzle BP. Oh, that's right. Okay. This thing is a default, so I set this cube up wrong. So I bet if I flip this to here and make this now the root object, so its root is a cube, I should now be able to go back to set actor. All right, if this is the issue, I'll quickly explain what I just did. I bet this was the issue. Yep, that was the issue. All right, so just as a quick one, since we're running a little bit over, what was happening here is that when I first created this puzzle pickup object, it had a default scene root as the root object, which the root object has no physics to it, which also has no transform. I needed this thing to be a base of a cube, which, sorry, I'm not gonna, damn. So as a separate, let me create a separate blueprint to show you what I did. So when I created a default actor, I'll call this test. The first thing it gets is a default scene root, which if you notice, this thing has no transform. So when I added a cube to it, I said set actor location, which would be trying to set his location, which he has none. I then instead saying, all right, instead of being a default scene root, which effectively holds nothing in it, I dragged cube up into here and made it effectively the root of this object. So this is now the root of the object. So if I change his location, it will now change because this thing is now an actor, which will have a transform in a position. So slight weird thing from Unreal. I forgot that was a thing. So this should now more or less be it. We're going to add on to this next Friday, but now I should be able to set the cube. I should be able, I wonder if I could just say set simulate physics now. Oh, still at the cube. Okay, that's fine. The last thing we're going to add is that on event tick, I'll keep moving it, but when I let go of the fire button, I'm going to effectively drop this object, and how I can drop it is that I'm going to set this reference to nothing, so null, so I no longer update it, and then right before I do that, I'm going to also turn his physics back on. So I'm going to take this. I'm going to say set simulate physics. I'm going to undo what I did. So I'll turn this back on. And then finally, I'm going to say held object is then equal to nothing, which if I don't put anything here, it's going to flip to nothing. So when I let go of my left mouse button, it's no longer going to update because this is no longer has something in it. I emptied the cup. The cup is empty, so this does not run. So when I run this, I can, sorry, got to add that in. When I run this, cube is picked up. Oh, I think I forgot to turn that back on. Set simulate physics, turn that back on. Run it. Pick it up, drop it. Perfect. Now I should be able to drop it on here. The door will open, which now I can move forward. Okay, so long one today. But so this was the basics of a pickup gun. We're going to add on to this, make it a little bit more colorful. I'm also going to add a little lightning effect to it. So for example, you can test this out, but I'll do this on event tick. So I also had this thing, you can test it out. So this is a cool little particle effect that I just made for fun right before this. I was hoping to have a little more time to get to it. So I'm going to say impact point drawn here. So I added a little particle effect, which will eventually show you how to do little particle effects. Actually, I'm going to do, no matter what, if I didn't hit anything, I'm just going to run this. Then on release, we're going to let go of it. Oh, this will only run once. I take that back. Actually, I'll just show you what it looks like. We'll add in the true functionality later, but I'll just show you kind of what it looks like. Oh no. I'll add it up in here, but I created a little lightning effect. Is this guy still working or not? Oh yeah, I think this one works. That's it. It doesn't look like. Where's my? All right, that one's broken. So I had to add it in. So I created I'll add it to the project, but I created a little lightning effect. So when you shoot the cannon, it actually creates a little lightning effect of where I'm shooting it at. I'll see what's going on there and add that back in. But the last thing I'm going to fix that error, I need to check to see if this is valid before I release it. So I'll get held. Is valid because I can't turn off his physics if there was nothing there to begin with. So I'm going to say execute. If this is valid, then I'll turn off the physics and then set it to null. Now this should be fully functioning for you guys to play around with. Oh, there it's working. Yeah, a little bit more to it. Perfect. It's also the noise is gone, and add that back into it. All right. All right, so this should more or less be good enough to probably add more stuff to your little game, add some little puzzle mechanics. Next week, we'll also add it that we have to do multiple things in the room. So right now, I just have to play it on the platform, but maybe we want the colors to be color coordinated. Maybe we want to have multiple platforms. We can add a whole bunch of things here, and we'll start adding more onto it. Is there any questions today before we call it? We went a little bit longer than I usually do. Any questions from the chat? All right. I will push this up online. So I'll put this under lecture 3 of where we ended at today. So if you want to pull it down and start adding stuff to it, if you have questions on it, please post it on my Discord. Again, thanks for everybody coming out today. I really like this project. We're going to keep adding more and more stuff to it. We'll eventually hit different aspects of the engine. So at one point, we'll actually talk a little more about animations, particle effects, physics, again, a whole bunch of other different modules. Eventually, we'll do a ray tracing talk. So I know we had a question on that. We'll eventually do a chaos engine. That's fun. The Niagara particle systems, Houdini. I'll eventually do a Houdini talk. But we're going to work up to there. Otherwise, thanks for everybody that showed up today. And again, this video will be on the YouTube, JDE YouTube channel. Will be on this Twitch page. You can go watch it. If you never need to reach out to me for more questions or looking for other people wanting to basically game develop, reach out to me or JDE. All the information is below in my Twitch page. If you need anything else, let me know. Again, thank you for coming out, and I will see you guys next week. Stay safe, stay happy.